Hi students, welcome back. Time to move on to the next phase of our journey. In this part, we are going to study about the chord, which is the second most important topic after tangents and normal. In this part, we are going to learn about different forms of chord. You will again see the importance of parametric form, and we will also see some important results which are combined using tangents, normals and chords. So let's start with the part. So starting with the definition of the chord, the line joining any 2 points of the parabola is called its chord. Okay, so in this, as I mentioned, the two major important lines when we are talking about the parabola lines. One was 3 lines I've drawn. So this we have already discussed many properties. Still we will discuss some more about this. And this one we are taking now, the part of it, a chord. Okay. So line joining, so you can take any 2 points on the parabola and join them. So that will be a chord. Okay. So now for getting the equation of chord, again it's not that difficult. Basic knowledge of straight line is required. So what we need to do, we know 2 points as 8t1 square, 2at1 and 8t2, 2at2. Okay. So slope from this will be twice of a t1 minus t2 upon if I subtract a into t1. This we have already done something like this equation, slope of a chord. Okay, so in that case that was normal, so it was more easier additional property, but this is basically the slope of a chord. Any chord, if you are finding, slope will be given by t1 plus t2, and now you know that you are having 2 points, you can find the equation. So if I simplify it for you, this will be minus, if I take suppose this point, so this will be t1 to a t1 will be equal to, this is the slope, t1 plus t2, and this will be equal into x minus at1 square. So on solving this, I am sure you will get equation like this. Okay, now again we will have, this is any general chord, means this chord has, like, we have taken nothing into consideration. The only point we have considered is that this is the equation of a line which is for which the 2 points are lying on the parabola. Now what is a focal chord? As you can see here in the board, so any chord which passes through the focus, suppose this is the focus, so if this passes through the focus, then this is known as focal chord. Okay, again from when we know that for parabola we are solving with respect to parabola y square equal to 4x. We have taken every parameter with respect to that. So when we are solving that, we know that the focus of this will lie on a comma 0. So this will clearly be passing through a comma 0 if it's a focal chord. So when you will substitute the values, now this is the condition. I'll highlight in some other color so that you can remember it for your reference. So this is the condition of focal chord, means a chord becoming a focal chord, the other side where it will intersect again, that will be. So what we have learnt, that if a chord is a normal, like obviously normal will be a chord if we are drawing a tangent and if we are like making a normal. So for that we studied that if for any normal, okay, the condition was minus t1 minus 2 by t1. Now for this case, if it's a focal chord, means passing through the focus, this s, then the condition is that this parameter will be a by t1 square, and this will be minus 2 a t1. So these are the two extreme points, very important result. Again we can see another term here which is known as chord of contact. And what is that? So from any external point, if we draw 2 tangents to a parabola, suppose like this, so if we join the 2 points of intersection, this is known as chord of contact. So chord of contact, basically from any chord you can draw 2 tangents. Why? Because it will intersect at 2 points, and these 2 points obviously you will You can see that you can find two tangents and see whether they will meet or not, and if they meet, then this chord will form the chord of contact. So we have discussed important lines till now, tangents, chord. So you just need to concentrate on the conditions, that the definition and the basic concepts. You can consider any line, and based on whatever the definitions of these lie, you can find. So tangent is most easier to remember, and then from tangent, if we are very clear about the tangent, we don't need to worry about the normal. Anytime we can like draw the conditions for normal. For chord, very important, we can take 2 points in the parametric form. Now here you can see that while we are studying all these lines, we are always taking points in parametric form. Now if there were 4 variables, it would have very difficult. Then we have to back substitute, we have to use these two relations plus y square equal to 4x. Now in parametric form, we have already make sure that we have used this condition. So we have avoided basically 2 steps in general. Let us see some important results. So regarding what we have done, equation of tangents drawn from an external point. So as said by me, that if you are having x1 comma y1, so the very basic method which I have already told was use this. Then from here you can put x1 y1, get x m1 m2 and get the equation of tangents. Now another way to do that is you can directly find the equation of pair of tangents using this formula. Now what is this formula? Okay, now S represents our curve, that is y square minus 4ax equal to 0. This is the curve. Now S into S1 means wherever this 1 comes, it means the equation at a point, equation of curve at the point S1 means x1 y1. So this will be y1 square minus 4ax1. Okay, and this t square, remember I have told you that for t square what you have to do, replace x square by x1, y square by y1, and if you are having only x, you will replace it by x plus x1 by 2. If you are having 2x, replace it by x plus x1. So depending on the situation, so this is what the t meant. Okay, so at this point you can, this equation, now you will see, now this is something, you will get something constant into 2 degree, and here also 2 degree. So here you will get pair of tangents. So you can substitute, and anytime you will see the questions in the test paper regarding these properties. Very important to remember. The next property is chord of contact. Regarding the chord of contact, so again it says the equation of chord of contact tangent drawn from the external point. Okay, so now again what we have seen, t is equal to 0 was equation of tangent at a point. So the difference between that is the point was lying here, then we are finding the equation of tangent. Now what we are saying, that this point is lying outside, like here. Okay, so what we are doing, we are like finding the equation of chord of contact. So if this is the chord of contact, okay, so this line will have the same equation, t equal to 0. So what you can do, you can again find y equal to mx plus a by m, and from there you can find m1 m2, and you can solve it with the parabola. Okay, the two equations, these two equations in green which I have made, this one and this one. Okay, solve it with the parabola, find the 2 points, you will end up in getting the same result. Okay, so you can do the derivation yourself, but remember, chord of contact is from external point if I am talking about this condition, and where there is equation of tangent when this point was lying on the curve. Okay, very important result, and this will help again lot, that you will be using again and again these conditions. Okay, next property is equation of chord with the midpoint. Okay, now you can find sometimes question where like it says like midpoint of chord is given by this relation. Okay, suppose y1 equal to something f of x. So based on that, what you can do, you will get x1 and y1,
as x1 fx1. So from this you can also find the chord of equation, chord of contact, the equation of chord of contact, or you can say equation of chord only. So that will be given by t is equal to s1. Now t was y1 minus 2 of 2a x plus x1, and s1 is nothing but y1 square minus 4a x1. So you can clearly see this is constant and this is 1 degree. So not an easy thing, but not a difficult thing, but again I would say you will have to read and write these things again one by yourself so as to remember it. And these three results you will see again and again many a times you will be used. So this will be a parabola if suppose this is midpoint. So in terms of midpoint we can find the equation of the chord. So again for derivation you can take 2 points, put the as we have done in the question session earlier. So same concept we will use and you will end up in getting the same equation. This one is nothing but this equation only, okay. So you can solve and you can try it, okay. Let's see the next concept, diameter of parabola. Again a rare concept, but again it may appear in the JEE Advanced, not a JEE main, but again JEE Advanced. So in this we have defined, we know that diameter of circle is the longest chord passing through the center. We have so, but in the diameter of this thing parabola, we don't have any center for a parabola, okay. So we define the diameter as the locus of midpoints of series of parallel chords. What do I mean? Now if this is a parabola, if I am drawing a series of parallel chords, these are all parallel chords. Now if I draw a line which is like passing through their midpoint, so now this is termed as a diameter of parabola. So again you can remember this result, you can also derive it, that the slope of the chord is given. Suppose we are taking this chord and the slope is given, then the equation of diameter will be y equal to 2a by m. So this is again not a difficult condition. So what you can do, h comma k take as the midpoint. So apply that condition, t is equal to s1. So from there you will find this equation, the equation of chord. If I go to previous slide, you will get this equation. So in this what you need to do, if you look at this equation, from here you need to find m. What will be your m? So clearly m will be here, from here you can club all the y terms together and x term will be having 2ax and this will be a constant here. So 2a will be your m here. So if this is known, then okay, this is y1 here, so this will be y1 here. So m is equal to 2a by y1. This will give you the locus of your y1, and this y1 we are saying in terms of midpoint is k only. So that in generalize you can replace it using hk, and general way you can replace it xy. So this will be the slope equation of diameter, which is again you can see parallel to the axis of the parabola. Again concept which can related to which questions can come.
If you have any doubt after seeing the presentation, you can just visit askIITian.com. There you can click discussion board, which will direct you to Ask Expert page. Here you can select the category of your question. Suppose if you want to post it in algebra, you can write your question here. If you have the question in the image form, you can just attach the image and click get answer. Experts at Ask IITian will answer the question within 24 to 48 hours. So we have learnt about different types of chords. We have learnt chord of contact, the common focal chord, and again we have also seen the important results which are directly applied in solving the questions. So in the next part we will see the questions related to topic which we have just done now, okay? So stay tuned for the next part.